Hey everyone, it's time to start looking at how RIPng is going to operate on non-broadcast multi-access segments in our network. Now, keep in mind, in the confines of Routing and Switching version 5, our non-broadcast multi-access environment is going to translate directly to our DMVPN. The dynamic multi-point virtual private network configuration is going to be necessary for us to be able to connect remote offices, and more often than not, we're going to run a routing protocol across that link. So what we're going to do is let's go in and start looking at, first of all, R5. So what I want to do is I'm going to come up here and I'm going to say show run interface tunnel 0. Now what we see here is I have a link local address and I have an actual what's referred to as my globally reachable IP address. And what I did is I just simply did 10, 10, 10, colon, colon 5, 10, 10, 10, colon, colon 19, 20, and 21 in order to represent the 3 devices that are located in the 3 remote sites on the right side of our topology map. Now, what we're going to do right now is I simply want to enable the RIP process on these devices, and then what we want to do is look at what the actual behavior is. So we're going to enable them, but remember, they're going to be in their own isolated group right now. So let me grab a highlighter here. These guys are going to be merely operating in their own RIPng environment, but I'm going to call it the same because ultimately what I want to do is I want to take this group, which is also RIPng, and I'm going to bring them together. But first, what I want to do is I want to illustrate the idea of how we use this, and we're going to note the basic operation of RIP next generation across an NBMA network. Has it changed since RIP version 2 for IPv4? Well, let's find out. So what I'm going to do is I'm going to go to my interface here, config T, interface tunnel 0. And I'm going to say IPv6 RIP process ID RIPng enable. And I'm going to turn it on for this interface. Now what I'm going to do is I'm going to go over to our we'll advertise a loopback too. Let's say interface LO0, do show IP interface LO0. Let's see if there's an IP address here, do show run. Is there a IPv6 interface, not tunnel, I need loopback 0. No, there's not. Let's give it one. So interface LO0, IPv6 address. And what I'm going to do here is I'm going to say, I'm going to give it first of all FE 80 colon colon 5 link local, then IPv6 address FE, not FE, 2001 colon 5 colon 5 colon colon 5 /64. IPv6 RIPng enable. All right, now with this currently running, do show IPv6 protocols. I see I'm running it on my loopback and I'm running it on my tunnel. So my loopback and my tunnel. So let's go over to R19 and do the same thing. So interface, do show run interface LO0. Well, I need an IPv6 address here, so config T interface LO0 IP address. It's going to be IPv6 address. It's going to be FE 80 colon colon 19 link local. Then what I'm going to do is I'm going to say IPv6 address 2001 colon 19 colon 19 colon colon 19 /64. And what I want to do is I want to run RIP next generation here. So I'm going to say IPv6 RIPng for the process ID enable. Now we need to look at the tunnel. Do show run interface tunnel 0. Now looking at the tunnel, I see I have an IPv6 address here, but I haven't specified an address to use for my link local, but let's just leave that off for the time being. Let's not mess with it. So what we're going to do now is I want to look at what's going on here. So first of all, I'm going to enable the process here. So I'm going to interface tunnel 0. I'm going to say IPv6 RIPng enable. Exit. Exit. We'll go over to 19 or 20 and do the same thing. Interface LO0 IPv6 address FE80 ::20 link local IPv6 address 2001 20:20 /64 do show run interface tunnel 0. And we have an IP address here, but I went ahead and configured a link local address on this one. So let's make that one participate. Interface tunnel 0. IPv6 RIPng enable. Interface LO0 just in case I forgot it. And then lastly we'll do 21. Do show run interface LO0 interface loopback 0 IPv6 address, and what I'm going to do is FE80 ::21 link local IPv6 address 2001 ::21 ::21 /64 IPv6 RIPng enable. Interface tunnel 0 do show run. Let's do this. Do show IPv6 interface brief. And what we want to do is we want to look at the tunnel. We have an IP address and we're good to go here. So let's have it participate. So interface tunnel 0 IPv6 RIPng enable. Show IPv6 protocols, and we see I'm running on the loopback and the tunnel. So now let's see what's being learned on R5. Let's take a look and see what's happening now. So exit, show IPv6 route RIP. Well, I'm learning prefixes, so here we go. Notice I'm learning these via the tunnel, and one of the reasons I wanted to do the situation where I didn't configure the link local address, look at the link local address that was automatically created. That link local address was created by taking the MAC address and inserting the value FF:/FE, and then also making a change to the second most least significant bit in the value and inverting it. So if we were to take a look at the MAC address that was generated for this particular device, what we're going to find here is that the IPv6 address that was created for my link local connection was based on that MAC. MAC addresses are 48 bits in length, and our IPv6 addresses are 128 bits in length. So what ends up happening is that we end up having to add some additional information to flesh the 48-bit mask into the 64 bits that we use in order to be able to create the first half of our IPv6 address. All right, now, let's see what's happening on our other devices. So on R19, am I learning any prefixes? Show IP route, IPv6 route. And let's see, route RIP. Now I'm learning about 5. Can I reach 5? Ping 2001:5:5:5. Yes, I can. Now on R20, am I learning any prefixes? Do show IPv6 route RIP. I'm learning about 5. Can I reach 5? Do ping 2001:5:5:5. Yes, I can. No, I can't. I can't because I fat fingered it. So there we go. I've got reachability. And lastly, let's check what's happening on R21. So show IP route, IPv6 route, excuse me, route RIP. And I'll have one entry, and that's going to be 4 or 5. So it's going to be ping 201:2001:5:5:5. Now that's the loopback interface, and it's reachable via my tunnel. But notice I have no reachability between my spokes. So right now if I say ping 2001:20:20:20, I have no reachability. Why? Because there's nothing in my routing table that's going to allow me to be able to find that address. So what we want to do is we want to, again, revisit the idea of the fact that this link or this connection that we're talking about is a DMVPN. And DMVPNs are going to be non-broadcast multi-access by default. So what we want to do is we need to recognize that RIPng on these DMVPNs and on these non-broadcast multi-access environments are going to use the idea of, and I'll get my head out of the way, split horizon. So the idea is that on this scenario, R5 is connected via a tunnel. But it's connected to 3 different devices, R19, R20, and R21. Now, as I learn prefixes coming in from R21, I'm learning it on tunnel 0. So that means I am not going to advertise them out the same interface that I learned them on. That's this idea of split horizon. So what we want to do is we want to recognize the fact that the behavior that exists in RIP version 2 with regard to NBMA connections, hub and spoke specifically, is the same process that we have inside of RIPng. So RIP Next Generation doesn't offer us any changes or benefit, and the way that we're going to do that is we need to go to the tunnel interface, and what we need to do is we need to turn off split horizon. So let's look at exactly what goes into that actual process here. So what we'll do is I'm going to go to R5, and what we're going to do is we're going to look in the wrong place first. What I'm going to do is I'm going to come in here and say config T interface tunnel 0, and I'm going to type no split. So no split. Now it's not going to give me any type of information regarding split horizon on this interface. That's because it's not an interface level command. What we'll do is we'll go to do show run pipe include router. Actually, we'll say section router. Now what I want to call your attention to is notice we have this value right here, IPv6 router RIPng. Now that's not a configuration that we entered in the system. The moment we enabled IPv6 RIPng enabled on an individual interface, the system, iOS, created this entry by default, and it is going to be the context where our RIP Next Generation protocol is running. So what we'll do is I'm going to go into there. I'm going to say IPv6 router RIPng, and now what I'm going to say is I'm going to say no split horizon, and I'm going to hit enter. Then what I'm going to do is I'm going to clear my process. Do clear IP route star. But that's not going to help me. I need to do clear IPv6 route star to clear the IPv6 routing table. So let's take a look and see what's going on now. So show IP route RIP. The question is am I learning anything via tunnel 0? Well, I am, but it's only because we did the previous configuration from last time. So do or show run section router RIP. Here's my RIP configuration, my router. Notice that I'm advertising the network 10, which means I'm participating via the DMVPN, and in the context of the system here, what I'm doing is I've disabled split horizon simply for the RIPng. So now I should have overridden the behavior whereby if I learn a prefix via an interface, I'm not going to advertise it out that same interface, and that's that idea of split horizon. Every once in a while I screw up and call it point poison reverse, and that's not what it is. But the idea here is it's split horizon, and the configuration command is actually entered under the router process configuration for RIPng. Let's take a look and see what's happening now, if anything. So on R19, show IPv6 route RIP, let's see what we're learning. Now notice we're learning about 20 and 21. I should be able to have reachability where I can now ping 2001:21:21:21. And I should be able to hit 20 as well as 5. So now that simple command has fixed my issue about the ability of not being able to learn about the prefixes that are also attached as spokes on this NBMA environment. Now what I want to do is I want to go ahead and kind of close this topology out. So for the last portion of this part of our presentation, all I'm going to do is take my two disparate RIPng environments and I'm going to connect them together, and I'm going to do that between Cat1 and R5. So let's make that happen. So what I'll do is I'll go over, Cat2 and R5. So right now, let's discover how we're connected. Show CDP neighbors. And what I'm going to see is I'm connected to R5 via interface E02. Do or show run interface E02. And I can see I'm using VLAN 205 to do that. So show IP interface brief, exclude assigned addresses. I see I have 205 configured. So let's go in and bring this up. So config T interface VLAN 205, do show run interface VLAN 205. Let's see if I have any IPv6 addressing on it at all, and no I don't. So let's add this IPv6 address, and what I'm going to do now is I'm going to come in here and I'm going to say FE80::12 link local IPv6 address 2001:12:12. No, actually, we don't want to do that one. We want to do 205::12/64. That's going to bring that link up. IPv6 RIPng enable on this link. Then we duck down to R5. Show CDP neighbors. How am I connected to Cat1 or Cat2? I'm connected via Fast Ethernet 01. So show run interface E01. I have no config, so let's go ahead and add that. Interface E01, IPv6 address FE80::5 link local. And what I'm going to say is IPv6 address 2001::205. Sorry, 205::5. Let me double check that, make sure that's the right config. 205, yes. So let's see if we got reachability. Do ping 2001::205::12. Well, with this we have no valid route. Let's see if I can reach the link local. Ping FE80::12. It's going to ask me about my interface. So it's going to be Ethernet 01. And I can ping. Let me highlight something else here. Notice if I come up here and say ping and I say E01, it's not going to work. It wants to see the actual name of the interface. So let's say I did capital Ethernet 01. That's still going to work. So it's not necessarily case sensitive, but it does want to know the actual name of the interface, whether it's serial, and it needs to be spelled out in full. So with that being said, let's see if I can bring this up. IPv6 RIPng enable. So let's see what happens. Let's go over to R21 now. Show IPv6 route RIP and see if we're learning any other prefixes, and we are. So let's just test this. Ping 2001:22:22:22. Actually, that's not going to be right. It'll be 222::22. And yes, I can reach it. So from R21, I have the capability of going through the DMVPN cloud up into my infrastructure, and somehow I'm making it to R22. Let me source it from my loopback address as another verification. So ping source LO0, and I also have reachability. And what we're doing now is, notice I'm using my loopback's globally reachable IPv6 address to accomplish this. So with that being said, I've demonstrated that I have connectivity, but let's see what the trace route looks like. So trace route IPv6 to 2001:222::22. And where are we going? Well, let's see. Let's follow it. I'll just grab a highlighter. And what we're doing is we're going from R21 to R5 via the tunnel. From here, what we're doing is we're going up to 12, which should come as no surprise. Then what we're doing is we're going up to R3, then we're going over to 2, and from 2, we're actually able to make it. Hold on here, that's not right. So from 3, then what we're doing is we're shooting straight across the serial link to R22. So that's going to be, again, based on the fact that RIPng is still going to rely on the hop count in order to pick the path. So we'll take the shortest path. So it's going to be 1, 2, 3, 4. Then what's going to end up happening is other options would be 1, 2, 3, 4, 5. So it's going to actually pick the one that we have. So in order to verify that, we'll go over to R22, show IP route to, so show IPv6 route to 2001::21, I'm sorry, :21::21, and hit enter. And what we're going to see here is our metric is 5. So when we look at this, it's 1, 2, 3, 4, and then 5. So it's very interesting how everything's operating with regard to our interconnectivity. So from here, the reason it's 5 is I'm tracking it to my loopback interface here. So what would happen if I just looked at it from the point of view of the interface connecting show IPv6 route 10, 10, 10, and I want to see 21. Okay, IPv6, picked the wrong prefix. 2001::, and this is going to be 10, 10, 10:::21. And see, there's why we have the 4. So from the point of view of the device, let's just track it one more time. We went from 1, 2, 3, 4, and then the last hop was to reach the actual loopback itself for 5. However, to reach this interface right here, it's only 4 hops because we don't have to do anything after we arrive at the entry interface on R21. So with that being closed, what we're going to do is we're going to call this part of our presentation to an end, and I'll see you guys in the next video where we're going to be looking at some of the more fundamental aspects of RIP Next Generation. I'll see you guys there. Bye-bye.